operational technology, or OT, network security challenges and solutions. So to start everything off, I wanted to thank our presenter, Baba Daio, for being with us today and hand it over to him to tell us all about networking, security challenges, and solutions.
For today's webinar, we will address how to identify some of the challenges and solutions related to operational technology and operational technology network security. Okay, so for the agenda, we'll first present an overview and evolutions of the operational technology OT networks in the enterprise. Then we will discuss some of the risks and challenges that we are facing in this type of environment. So in addition, we'll talk about some of the solutions and strategies for securing OT networks. And to finish this webinar, we will introduce a mini case study. This is just to give you an insight about how we can use some of the solutions and strategies that we will discuss in this webinar and implement that in a real production network. So, but before we can even go further, let's just take our time and try to define what is an OT network. Once we do that, it will help us have a better understanding, and this will be very good for going forward, so to understand basically what is an OT network, operational technology network. So, according to Gartner, this is just coming from Gartner, an OT network, operational technology network, is any hardware or software that is mainly dedicated to control system. So how do you manage and control these, how do you manage and monitor this control system in your environment? So whereas IT is defined as being your traditional business and administrative information processing that you have in your environment. And generally speaking, IT does not include anything that do not generate data for enterprise use. So this is just to give you an overview based on Gartner definition. So we'll come up with our own definitions later in this webinar. We'll provide you our own definitions of what is an OT and what is an IT. Okay, so just like in the IT space, in the OT space also, we do use some terms to characterize this type of environment. And as you see here for this diagram, so the OT is a system, and that system encompasses many subsystems. For example, ICS, which is the industrial control systems, and SCADA. These two are both subsystems of the OT network. But even though sometimes we use this very loosely, so it's very frequent for people to interchangeably reference ICS like SCADA. But SCADA is the control and data acquisition for manufacturing, and ICS is the industrial control system. So I just wanted to give you some of the terms that we often use in the OT space. Okay, now for the sake of simplicity, let's just take, let's provide our own terms of how do we define IT and OT. So IT will be referenced as anything related to our business and administrative process in our organizations, whereas OT, on the other hand, is mainly dedicated to industrial operations. So usually OT, they don't deal with any administrative or business processes in our organizations. So, and I just want to give you that simplify that definitions for IT and OT. So example of OT could be a production line management in a manufacturing, or maybe mining operations control, and so on. Okay, so you probably heard these terms, IoT and IIoT. So in essence, we'll define IoT as being any device or system that produce data exchange, unlike your a regular laptop or PC. So these devices usually they produce data that are not for human-to-human interaction. So, for example, your security camera might be considered as an IoT. But if you move to the industrial space, that same device might be referenced as IIoT, Industrial Internet of Things. So that's the only thing that I want to highlight in this slide. So devices that we reference as IoT in the IT space might be referenced as IIoT in the industrial space. And I just want to leave it as that. So anyway, so usually and traditionally, OT systems were very siloed. What do I mean by that? Generally, we used to have dedicated teams that are managing and operating this type of networks. And on the other hand, we also have dedicated team managing the IT space. So, but recently, you notice that many organizations are forced to collect data anywhere they can collect data. And I'm not saying that they were not collecting data before. They used to collect data in those control systems, but they used to use manual processes. Nowadays, we are forced to collect data in real time, just like we are doing it in the IT space. And because of that reason, now the IT and the OT are coming together as one unique network. And we are merging the two together. And this is really very important. So just before, we have a different system for IT, different group managing those systems, different team for OT, and different, everything was separated. But now the line is disappearing. As you notice here, it's very difficult to specify where IT starts and where OT ends, and vice versa, because we are putting them together as one network. Some of the risks associated to these type of environments. So one of the things is the criticality. These networks, these systems are very critical just because they are the system that we use to produce services and products in our environment. And any small problem in those services might impact financially your organizations. And we are not saying that it's not the same for the IT environment, but let's just give you an example. Let's say you manage maybe the power grid and it goes down for more than a day or 2 days. That's disruptions might not only have financial consequences for your organizations, but at the same time, it might even impact the life of people or the life of the patients in a hospital. These are some of the risks associated to these. And if going forward, we want to associate or merge these two networks, we need to understand all the risks associated to this type of environment. Okay, so now before we have we just said that now the governance of the OT is falling under the responsibility of the IT. So now we have the IT, because we are merging the two together. The IT team now will be responsible going forward to manage this type of environment. So that's why we need to pause and rethink. We need to rethink the processes. We need to make sure that we understand, because the IT team might not have the knowledge required to manage those type of network. They might not have an understanding about all the risks and threats associated to these type of environments. That's very important going forward to retrain this team so then they have a better understanding of how we can manage these type of environments. So we need to create new processes. Maybe we need to add new procedures and even add some new standards that will allow us to make sure that the IT team might have the knowledge required not only to manage these environments, but also to understand all the threats and vulnerability associated to this so that we can protect this environment better. Now, we do have some challenges with these systems. One of the problems that we face in these type of environments in the OT network is the fact that they tend to use legacy devices. It's not uncommon to see some control systems that are more than 20 years old. It's not uncommon to see, for example, outdated operating systems such as Windows XP in those environments, or even Windows 3.1. You might be surprised, right? So if we want our IT team now to manage these systems, we must make sure that they have the tools required to support those systems. But if they use outdated systems, we might not have the tools to support Windows XP or Windows 3.1. So, and even if they do have that support available, so because of the nature of these type of systems, it's really very difficult. Because of the high availability factor, it's very difficult to upgrade those systems because you cannot upgrade them while they're on productions. You have to wait after. So what I'm trying to say is usually the functionality supersedes the capability or even the vulnerability of those OT systems. And the last point I want to make here is because of the nature of these systems, it's truly very difficult because they're systemic systems. And one small problem, right, on one system can disrupt the entire system. So these are some of the challenges that we really face with this type of environments. Okay, so now again, it's not like we didn't have some standards. There are some standards just like in the IT space. In the OT space also, we have some standards that we use in order to provide guidance how to secure these type of environments. And the Purdue model, this model was designed to provide that guidance for industrial infrastructure. So I'm not going to spend too much time on this. I will later show you how we can use that model and implement that in our network. But I'm sure you can do some more research about the Purdue model. But all the Purdue model, it was invented in the 90s, and all the Purdue model is providing to the OT space is to provide a blueprint how we can segment our network. How we can segment our network. Okay, so now, even though the Purdue model provides that segmentations and recommendations, it also provides some recommendations how you're going to do that. The Purdue model does not specifically provide, how you're going to do it. So it's up to you how you're going to use the Purdue model and how you're going to implement that segmentation. So most of the time, we use VLANs and firewalls to do that segmentations. And there are so many different organizations right now that are dedicated to produce devices and equipment that are really adapted to this type of environment, to the OT network. So one of the examples is WorldTech. And WorldTech is producing a firewall. This is the name of the firewall, Upshield. And WorldTech is also owned by General Electric. These firewalls are dedicated to protect your environment in an OT network. So we also have Cisco. Cisco has many systems, so it also has these industrial switches, the Catalyst IE 3300. And these catalysts are designed and they are hardened to support these type of environments. And they also run protocol, industrial protocols such as the CIP, which is the common industrial protocol. But not only that, these switches can also adapt to your traditional IT environment. For example, they can run at the same time, they can run VLANs, port security, etc. At the same time, they can run the CIP protocols for automations for your network OT environments. They can also support your traditional IT. So Cisco has also other products. For example, the IND, which is the Industrial Network Director. This is a very futuristic tool that you can use to manage your industrial networks. And if you need additional information, my recommendation would be to contact your sales rep, Cisco sales rep, and they will be able to even provide you with more information about, and maybe give you a demo so you can learn about how feature rich this type of tool is. Okay, so now the solution and strategy for this type of environment. So we are using VLANs and Firewall to implement that segmentations, right? But segmentation would, so for example here, one of the major problem we face, if we only use a VLAN, and let's say there is a breach on that VLAN, so it will impact any system, any control system that is attached to that VLAN. This is because of the same trust relationship that exists. So if one control system is impacted or is compromised, every control system from that same VLAN or within that same VLAN is at risk. And the same thing applies true for zone. If you use zone to segregate these compartments on your network. So just to kind of give you an illustrations about organizations that are just using a single VLAN in those control system and multiple cells. So let's say here I have one VLAN that I'm using here. It's a VLAN 5. I'm using a single VLAN, but I have multiple production cells. Maybe this is for my for cell number 1. Maybe this is for the heat treat, and this is for my coding. So what is the problem with that? The problem is obvious. So if you use a single VLAN, multiple cell in your environment, so if we have a breach here, let's say this control system is compromised, so it's easy to propagate that virus or malware to the other control system within that same cell, but also it's easy to propagate that to a different cell because you share the same VLAN. Okay, so but why don't we use multiple VLANs? So each cell we have a unique VLAN, just like you see here. So each cell we have unique VLAN here, VLAN 6, and for cell number 2 we have VLAN 5. You might say this might resolve the problem, but wait. You know that in your environment, if you are a control engineer, you know that these production lines, they don't sit there forever. So from time to time, you have to reprovision them, you have to repurpose them. Let's say now this is VLAN 5, and this is my VLAN 6. and I need to repurpose this particular control system, and I want to move it from cell 2 to cell 1. So in the IT, you have to, if I'm the engineer, the control engineer, I might not have the administrative right to configure this. So I need to call help desk. And sometimes when you call help desk, they have to create a ticket for you. So they're going to assign that ticket to somebody from IT who has administrative right, who can access to the switch and maybe log into this port, to that switch remotely, and configure that port from VLAN 2, from VLAN 5 to VLAN 6. And if you are lucky, this can be done within 1 or 2 hours. But if you work in that type of industry, you understand that it's not going to happen. You don't have time. The control engineer does not have time to wait 2 hours for somebody else to remotely try to configure this. I just want to come in, right? Unplug the device, plug the new device, do my configurations, and voila. So this is some of the problems that we face. Sometimes when we provision this, we want to do it as quickly as possible. Okay, so what is the solution? Solution is microsegmentation. We want to microsegment the network so that if we have, or if we experience one problem, that problem cannot be propagated to another cell or to another zone. Microsegmentation is what will limit the propagations of that malware or whatever threat that you are experiencing. But microsegmentation, any microsegmentation must allow easy deployment. Not only that, we have to do it with minimal configurations. I don't have time, if I'm the control engineer, to wait for somebody from the admin team to access to the device and configure that 2 hours later. I want to do it now. So if I am doing repurposing also, microsegmentation should allow me easy repurposing with minimal configurations. So this is the solutions. Microsegmentation is my solution. So TrustSec is providing you with that microsegmentation if you use TrustSec. If you ask me, Baba, how do I make sure that I can microsegment my network so that it will allow me easy deployment and easy repurposing with minimal configurations? My answer to you will be TrustSec. TrustSec has that capability to dynamically assign a tag, and this is the key, a tag, security group tag. When the device or the control system connect to the network for the first time, TrustSec will assign a tag dynamically to that device. And then you will need a policy, a centralized policy that will dictate how intercommunications between those cells or intra-communication between those cells will take place. I don't need to worry too much about the VLANs anymore. Even though we are not getting rid of the VLANs, TrustSec is complementing the VLANs. Okay, so let's just take some time and try to explain this. Now, I have to warn you, by any means, I'm not trying to explain TrustSec for 5 or 10 minutes. If you take Cisco class, you will spend at least 2 days trying to understand the concept of TrustSec. So I'm just trying to give you an overview how you can use TrustSec and micro-segment your OT networks without having to use VLAN only or firewall only. You still need to use VLAN and firewall. For example, you can see here, I'm using one VLAN here. It's VLAN 5. I'm using one VLAN and multiple cells. So how this is working, let's just try to go through it. So when a device connects to my network, I need to authenticate that device first. Who's doing that authentication? ICE, Identity Service Engine. So this is not to be confused with ICS. This is Identity Service Engine. This is a Cisco identity management that is very well known. And this is used to centralize your authentications, your authorizations, and you can do many more, profiling, posture, and so on. And TrustSec. So ICE, being my identity management, so we'll make sure that before any device or control system access to my network, I will first authenticate you. Once I authenticate you, now I'm going to learn some of the attributes dynamically, then I will assign a tag. For example, if I know that this control system must be in cell number 1, and I want to assign cell number 1 a tag, everybody in that cell tag 10, then I'm going to assign tag 10 to that. Who's doing the assignment? This is going to be that switch. The switch is the network access device that is directly talking or communicating with the control system. And he knows the switch can enforce any policy coming from ICE. ICE is not enforcing. The switch is the one that enforces that type of. So the switch will, based on information it received from ICE, will assign this tag, this device tag 10. If anybody in this cell who need to participate in that cell, we assign them tag 10. And same thing for here, tag 20. And remember, this is done dynamically. So now, once we assign that tag, any communications going forward, the tag will follow you. For instance, if I am trying to go and communicate with this, it's almost like the tag will follow you wherever you go. And at the end, so we're going to create a central policy here, and we're doing it locally from ICE. So I shouldn't say locally from ICE, actually we centrally configure that policy from ICE. So for example, it's very simple. This policy you see here is not based on IP address. It's only based on tag. I'm creating my policy, and I'm saying, so if tag 10 wants to communicate with tag 10, allow it. So I want to allow intra communication within the same cell. Anybody within cell 1, I want you to communicate with each other without any restrictions. Same thing for tag 20. Anybody within cell number 2, I want to allow some type of communications. But everything else I'm going to deny. By the way, I didn't even have to do that, because if it's not explicitly allowed, it will be implicitly denied. Okay? So now I microsegment my network. If you are part of cell 1, you cannot communicate with cell 2. So you see, ICE, which is my identity service engine, is what we use. In addition, ICE has many features, and security group tag with TrustSec is one of the features that we can use. So it means when any device control system connect to my network, my first thing is to make sure that we authenticate that device. Once we authenticate that device, I will then assign a tag. And ICE will be responsible to distribute those tags. So all the policy will be configured from ICE. And these devices that you see here, a switch, routers, and firewalls, these are the enforcers, because these are the network access devices that are directly connected to those control systems. So then if ICE has to enforce a policy, it will indirectly send it to those devices, and those devices will enforce the policy, whatever policy. And this is actually done dynamically. That's what makes ICE beautiful, because it's dynamically, it can change the authorizations anytime, or the policy anytime. So this is, I think it's important to illustrate how we can use the Purdue model to try to show you an implementation in a real production network. So for example, the Purdue model provides guidelines, a blueprint of how we can segment our network within that area. So for example, you might have your enterprise zone, which is basically your IT zone. You have your demilitarized zone, and the demilitarized zone is where you can place, maybe if you want to allow any service access from the internet, or even you want to use some shared services like your DNS servers, Active Directory, and so on. And then the manufacturing, this is where you have all your cells, right? And you see, you might create multiple cells or multiple area, multiple zone in that manufacturing zone, and then you have the safety zone. So what we need to do is, between each zone we put a firewall, and between each cell we put a VLAN to segregate them. Or now, because now we can use TrustSec, we can use TrustSec for microsegmentation. So let's illustrate that. For example, here I'm focused here to this is my manufacturing zone, and I provide a VLAN 5. So every zone you probably will use one VLAN, and within that zone is subdivided with multiple cells. I have cell 1, cell 2. Now notice here, each cell I was able to use TrustSec to assign a unique tag. So in some situations in your organizations, you also need to allow your control engineers to come within those within the manufacturing zone, so they can do some configuration or repurposing. So that's why we might have here a monitoring zone, stations, right, within the manufacturing zone. That monitoring stations will allow these engineers to be able to access to some of the control system within the manufacturing zone. And again, we use a firewall to protect that manufacturing zone against the enterprise zone, against the DMZ. So we also use a firewall to segment and separate against the safety zone. This is just an illustration to show you how you can implement the Purdue model. So now, ICE, Identity Service Engine, is playing a major part here, because ICE is what will allow us to do the microsegmentation. Okay, so sorry. So now, just to illustrate here, let's just talk about this is actually a project that I work on, and this was for a company. I'm just for protecting their privacy. I'm just going to call them an Acme Inc. Right? An Acme Inc. So that's important. So now, when we were approached by this company, they had some specification and some requirements. So what they were doing at that time was they were just using VLANs and firewall to do microsegmentation. That's it. So they were not doing truly, they were not doing microsegmentations. Right? They were just only using VLAN and firewall. So now, one of their requirements was, okay, we want to make sure that we protect our facility and make sure that in our factory, if there is an attack in one cell, it won't impact other cell. And then the other concern that they had was, we want to protect our intellectual property. We don't want anybody to physically or remotely exfiltrate or steal our intellectual property. These were the specifications from that organizations. Okay, so now the solution that we presented and we used was ICE and TrustSec. So we implemented ICE and TrustSec by using a security group tag. So essentially, for each cell, we use a unique security group tag, and that's how we did that segregation within the cell and between two cells. And we also allow some communications with the DMZ, because they needed to have some shared services to access to the DMZ. So then we use ICE to create a policy to allow that communication from the manufacturing zone to the DMZ. So, but we face major challenges, just like any project you go through. So when we use ICE in your IT space, it's truly very easy to collect attributes or profile these devices, because these devices, they produce maybe some traffics. And for example, if they want to have IP address using DHCP, or they might be generate HTTP traffic. So you can use a user agent, for example, for DHCP or HTTP, to learn about the operating system. Is it Windows 7 or so? We have some attributes that we can collect easily from those devices. But this is not the case in the OT network, because when you profile this device, if I want, for example, if I'm a control engineer and I want to put, I have two cells, one is for my heat treat and one is for my coding, how do I make that distinction? So this is based on functional attribute. This is not based on attributes such, for example, if I want to, in an IT space, you have your printer or your IP phone. It's easy to collect some information about a printer or IP phone, and you can deduce that this is actually a printer or this is an IP phone. But if I want to use a control system and place it in a heat treat or in a coding, in manufacturing, this is not that obvious. Okay, so we propose to the customer to use IND, which is Industrial Network Director from Cisco. And one of the features was we have a self-service portal. We want to make it very easy for this control engineer when they access to do it, the provisioning very easily. Unfortunately, for that particular project, the customer was very excited with that project. But for that particular project, some of the attributes, IND did not fulfill all the customer requirements. So what we did was we worked with a third-party company. This is a company that is an IoT, that has an IoT applications that was really customized for the classification process. And again, all I'm trying to explain here, to illustrate here, is how ICE is extremely flexible. You don't have to use something that Cisco has invented, you can use any application, any custom applications, and integrate that with ICE. That's what I'm trying to illustrate in here. So we were able to work with that company, and if you need additional information, maybe you can send me an email later. But that company was able to create, they were actually designed to create this classification for us, and we were able to integrate that with ICE using REST API and PXGrid. PXGrid, which is platform exchange grid that allow you to integrate with any platform in your organization. So some of the features that we have with that customer was it was using just like the IND self-service portal, so that we can easily assign an OT device to a particular cell. And the other feature was it was providing us visibility. And by the way, even the asset management team, they approach us and say, hey, we want to use this because oftentimes in our factories, people just go and grab a device and then plug it into our factory, and we don't have any visibility. So we want to use these to do asset management, and we were able to accommodate them. So the other feature here is that application were able to provide also high availability for database. Okay, any questions?
Okay, so I have one here. So can OT security products, for example, TrustSec, communicate to Subsystems, for example, QRadar, in order to provide a more holistic corporate security monitoring and event management system?
Okay, so this is possible. We can do that, but it's done via ICE. You can use Identity Service Engine to provide that communication with those type of devices. So you can integrate any SIM if you want with ICE, if you want to. So ICE can make that. TrustSec and Security Group Tag is just one functionality of ICE, but you can use any SIM and integrate that with ICE if you want to. So TrustSec is basically just the microsegmentations feature that you use from ICE to microsegment your device. But if you want to integrate with a third-party device, just like we said here, if I move on here with the PXGrid. So here, for example, let's say you have, let's say I have my StealthWatch. StealthWatch is a device that collects informations, net flow informations, or maybe I have maybe FMC, Firepower Management Center. I can integrate all these with ICE or any other SIM for that matter. I can integrate that using PXGrid. So PXGrid again is that feature that allows you to integrate ICE with many other systems out there. They don't necessarily need to be Cisco. Cisco is working with all these different organizations to allow you to integrate with any organizations, any platform.